All right, so we talked about arithmetic sequences in our last section, and now we're looking at the other piece of the arithmetic information, which is the series. So a sequence is just a list of numbers, which is what we learned yesterday. And now we're going to be looking at the series, which would be adding up that list of numbers. Okay, so these can be finite, which means they have a beginning and an end, or an infinite sum, and I'll talk about those later. All right, so just as an example, an infinite sum would go on forever, and finite would have a beginning and an end. All right, so we need to understand what sigma notation is in order to do these. So sigma notation is this big, fancy looking E. Okay, so looking on the left here, this right here is sigma. We have the starting number and we have the ending number, and these numbers in between 4 and 9 go into the formula. Okay, so over here I've written out the work for this. So the formula is n minus 2. So instead of writing an n right here, we start with the first number, which is whatever's on the bottom. So 4 minus 2, and then we go all the way up to 9. So 4 minus 2, 5 minus 2, 6 minus 2, 7 minus 2, 8 minus 2, 9 minus 2. Okay, simplified would be 2, 3, 4, 5, 6, and 7 added together, giving us a grand total of 27. Now, whenever you see this sigma symbol in math, because you will see it in future math classes, it simply means add up everything together to one single number. Okay, so we're going to practice doing this on the next page. So right here we want to expand these, so actually write out what the numbers are and then add them all up. So the formula right here, 3n, instead of putting n there, we're going to start with the bottom number under sigma, which is 1, and then keep going up, so 2, 3, 4, and 5. And then we're simply going to add those together. And we get 45. Okay, so that is expanding it. That's what we did right here. That is this part of it, expand, and then find the sum. We just add them all together. So the homework is going to ask you to do that. Let's try this one. Okay, so this formula has absolute value in it, which just simply means that your answer is going to be positive each time. Okay, we have our starting number and our ending number. So let's do this. We've got 5 minus, now our first number is always whatever's on the bottom here. So 5 minus 3, 5 minus 4, 5 minus 5, 5 minus 6, 5 minus 7, and 5 minus 8. I'm going to simplify this a little bit. We've got 2 plus 1, 0 plus 1 plus 2 plus 3. Notice these right here are positive because when you take the absolute value of a negative number, you get a positive number. Okay, so we really have 9. Okay, so that's expanding the formula again, and then just adding all of your numbers up. All right, let's try this last one here before we get into using the formulas, because remember this chapter we're using a lot of formulas. All right, so this one starts with 4, and then the last number we put in is 7. So we've got 5 to the 4 minus 2, 5 to the 5 minus 2, 6 minus 2, and 7 minus 2. Okay, so I'm going to simplify this a little bit. So this is really 5 squared, 5 to the third. Okay, put this in the calculator. 3,900. All right, so that is sigma notation. So we just need to understand how that works, knowing that we have a formula on the right, and then the numbers that we put in range between the bottom number to the top number. Okay, but we're not going to be doing this by hand most of the time unless it says expand it and find the sum like we were doing here. Most of the time we're going to be relying on the formula. Okay, so the series formula for arithmetic sequences. Okay, so we're going to look at that right here. Okay, so this is the arithmetic sum formula. Okay, so S sub n, S simply stands for sum. Okay, we're going to need the number of terms, that's n, then T1 and Tn, that's the first term and the last term. Okay, so sometimes they're literally going to give you exactly what you need, so don't overthink these problems. Okay, so our formula again up there in blue, we're going to take 40 terms because we want to know how many numbers we're adding up, so that goes there. And then all we do is we add the first term plus the last term, and we divide by 2. Okay, so we can put that in the calculator and get the total sum of those numbers added up without having to actually write them all out and punch them in. $3,420. Now they're not always going to give you those three things, and we have to rely on the formula we learned yesterday to find whatever missing information we need. So we're going to be using the formulas from yesterday and today together on most of the problems. So looking at this example, we need to find the sum. Now, there's always three things we need in order to find the sum. We need how many numbers we're adding up, the first term and the last term. So on this one, this dot, dot, dot simply means that there's numbers in between there that they're not listing. Okay, so we do have the first term and the last term, but we don't have how many numbers there are. So we're going to use yesterday's formula to figure that out, to solve for n. So again, yesterday's formula is this. We're going to put in everything we do know. So remember, by the way, an is the same thing as tn, a1 is the same thing as t1. And both of these right here are referring to the last term, and these are both referring to the first term. Okay, so right here, an, down here at the bottom, an is the last term, so that would be 10, equals a1, which is your first term. We are trying to figure out how many numbers there are, so we leave n as n, because that's what we're solving for. And d, the common difference, this one is going down by 2, so we put -2 there. So now we just have to solve for n. So this part is the easy algebra stuff. So we distribute this -2. We combine like terms. Minus the 52. Okay, so 21. The number of numbers in that list is 21. So now we can use the formula up above to figure out what the total sum would be. Because now we know that there are 21 numbers, and we know that the first term and the last term from our list over there, 50 and 10, and we divide by 2. We get 630. So these formulas are going to be used hand in hand quite often. All right, so moving on, find the sum of the following arithmetic series. Okay, so we've got our formula. We know we need the number of numbers, and then we're going to add together the first and the second, or the first and the last terms, and divide by 2. Okay, so the number of numbers, well, let's think about this. If we start with 1 and we put in all of the numbers all the way up to 100, how many numbers is that? Well, that would be 100 numbers. Okay, so that's the number of numbers. And then how would we find the first term? Well, let's think about when we were expanding these a couple pages ago. All you do to find the first term is to put 1 into the formula. How do you think we find the last term? We take this number, put it into the formula. So we've got 500. We've got 5 for the first term, 500 for the second term. We get a grand total of 25,250. Okay, this is another one where we don't have all of the information, so we're going to use the other formula to help us. So we know n, because there's 75 numbers. We know the first term is 4, but we don't know the last term. So we're going to find that. So an is our last term. I'm going to use the formula from yesterday. So our first number is 4. We know n is 75. And let's look at the common difference. Common difference looks like it's going up by 3. We punch this in, we get 226 for our last term, the 75th term. Okay, so we'll use our formula for the sum. We know there's 75 terms. First term is 4 from the list. Last term we figured out is 226, and we divide by 2. $8,625. Okay, always looking for those three things, the number of numbers, the first number, and the last number. And you can find the sum of any arithmetic sequence. All right, let's try this one. List the first 3 terms of the series. Okay, so we need to figure out what the first, second, and third number in the list would be. So they've given us some information. We know the sum of the entire list. We know that there's 28 numbers and that the last number is 228. So we're going to start with the formula. And we're going to put in what we do know so that we can solve for what we don't know. So they told us the sum. We know the number of numbers is 28. We don't know the first term, so that's what we're going to figure out, which will help us because that's what we want right here. And then we know the last one is 228 divided by 2. All right, so we need to solve for a1. So let's get rid of this 2 first by multiplying by 2 on both sides. $5,964. Okay, now you have 2 options at this point. You can distribute the 28, or you could get rid of the 28 by dividing on both sides. And we get 213. So now that 28 is gone, and then we can subtract on both sides. -15. Okay, so now we just need the common difference. So yesterday we learned the shortcut to that is we take, so we know A1 is 15, and we know that A28, the 28th term, is 228. So we take 228 minus 15. Remember, we take this number minus this number, and then we subtract the little numbers below it. So we get 9 when we subtract that -15 up there. So now we just know that we're adding 9 each time, and we can easily fill these in.